Okay, functions, page 14. For each of the following functions, do the following. First, you're going to find the inverse function. Then you're going to sketch the function, the inverse function, and y equals x on the same set of axes. And then you're going to demonstrate that the inverse function following the function, or the function following the inverse function, is x, the inverse function. Okay. So let's first find the inverse function of 2x plus 5. The way you do that, remember, is you do variable interchange. So you have y equals 2x plus 5. We're going to put x equals 2y plus 5, and then we're going to solve for y. So we're going to have x minus 5 equals 2y, and then we're going to have y equals 1/2 x minus 5/2. Okay, so this is our inverse function. Okay, so we found the inverse function. Now we're going to sketch the function and the inverse function. So I'm going to sketch the function in blue. So 2x plus 5, the way you sketch 2x plus 5 is you find the y-intercept, which is plus 5, and then you're going to draw the slope, which is rise 2 over run 1, and it's going to look about like that. Okay? And then I'm going to draw the inverse function in red, and the inverse function is y-intercept negative 5/2, which is 2.5, and the slope is 1/2, which is rise 1, run 2. Okay, so it looks kind of like that. Okay, and then last of all, it says for us to draw the y equals x on the same set of axes, so I'm just going to draw that with this green line here. And you can see it goes right down the middle. You see that the blue is a reflection of the red over the mirror green. Okay, so we've done that, that's 2. And then finally it says show that the inverse function following the function is equal to the function following the inverse function, which is equal to x. So let's try that. So what we're going to do is we're going to take the function, and then we're going to take the inverse function, and we're going to have one follow the other. So first we're going to have the inverse function following the function. So the function is 2x plus 5, and then afterwards we're going to follow it with the inverse function. Okay, and then we'll see what we get here. We're going to get x plus 5/2 minus 5/2 is equal to x. Okay, so yeah. So the first one we've shown. Next, we're going to say f follows the inverse function. So first, we're going to have the inverse function, and then we're going to follow it with the function, which is 2x plus 5. Let's see, now we're going to have x minus 5 plus 5, and yeah, same thing again. Okay, so we've proven it. All right. Now, the same one's the same thing. I'll just give you the first step. Instead of putting y equals 3 minus 2x over 4, you can break it up. You could say y equals 3/4 minus 1/2 x, if that makes it easier to graph for you, because now the slope is here and the y-intercept is here. So it's separated out. It makes it easier for you to graph, right? Okay. All right, moving on. We'll do a couple of these. These are really easy. Remember that, and to help us out, we'll draw the y equals x, what do you call it? The identity function through the middle. It's like a mirror. Okay? Once you draw the identity function, it makes it easier to reflect over the function to the other side. So you just basically draw each point, reflected over the green, and so you just end up with this function like that. Do you see? This would be at y equals -2. This would be at x equals 5, for example. Now this one would be at x equals 4, and then it would curve off like that, just like a reflection. This one would kind of be like that, and this would be at point -3. Okay, this one would be like that, and that would be at 1, for example. Okay, the reflection of this line is the same line, right? It's already a reflection of itself. Same with this one. Already a reflection of itself. Okay, so I didn't use a dotted line. I used a green line for y equals x. Okay, let's see. Go down to number 4. For the graph of y equals f of x given in 3a, state the domain of f of x, the range of f of x, the domain of f of negative f inverse, the range of f inverse. Okay, for 3a. 3a was this one. Okay, so the domain of f of x for 3a was, let's see, the domain was like between -2 and 0, right? So I would say -2 and 0, x is between -2 and 0, inclusive. Okay? Now what about the range of f of x? The range of f of x would be 0 to 5, right? 0 to 5. Okay. So that would be B. And then what about C? C says the domain of the inverse function. So the domain of the inverse function would be like that. It would be from 0 to 5. C. And then finally the range of the inverse function. The range of the inverse function would be that range there. It would be range from 0 to -2 or from -2 to 0. Okay. Now they want you to notice something. This is the range of the inverse function. This is the domain of the inverse function. This is the domain of the function, and this is the range of the function. Now, do you see how they match up? Like, look at this. This looks like that. This looks like that. The only difference is the x's and y's change. And that makes sense, right? They're mirror images of each other. The x's and y's inverse, but like the domains and the ranges like inverse. So the domain of the function is the range of the inverse function. The domain of the inverse function is the range of the function. That's what we've shown here. Okay? And so that is the end of page 14.